In the mountains of Lebanon stands one of the most ambitious construction sites of the ancient world. At Baalbek, three enormous limestone blocks form part of the raised platform beneath the Roman temple. Together, they are known as the Trilithon. Each block is commonly estimated to weigh around 800 tons. Yet these stones were not shaped where they now stand. They were extracted from a quarry, transported across uneven ground, raised into position, and fitted into a monumental. Nearby, even larger blocks remain unfinished in the bedrock as if the builders reached the limits of their plan. No lost civilization is required to explain. The surviving evidence points toward an extraordinary Roman building, but one question remains. How did ancient engineers move stones heavier than almost anything their world had ever attempted, and why did they choose to build on such an enormous scale? Baalbek stands in Lebanon's Bekaa Valley, between the Lebanon and Anti Lebanon mountain range. The region had been occupied long before the arrival of Rome. But during the Roman period, the city, then known as Heliopolis, became the site of an enormous rebellion. Its most dominant monument was the Temple of Jupiter. Only 6 columns remain standing today, but each rises almost 20 meters above the surrounding ruin. In antiquity, they formed part of one of the largest Roman temples ever constructed. The temple stood on a massive elevated platform. Along the western retaining wall, builders installed 3 unusually large limestone. These are the stones. Each measures roughly 19 meters in length, although published dimensions and weight estimates vary. Their size alone makes them exceptional, but their position makes the achievement even more difficult to understand. The blocks were placed several meters above the surrounding ground and fitted tightly into a wall made from other massive stones. The quarry that supplied much of this limestone lies less than 1 kilometer from the temple complex. Several enormous blocks. The most famous is known as the Stone of the Pregnant. Archaeological work has also revealed other unfinished stones, including one even larger block still connected to the bedrock. These abandoned monoliths provide important. They show where the builders worked and preserve traces of the quarrying process. They also reveal that the Romans were attempting to produce stones larger than those eventually installed. Why they chose this scale is still debated. Enormous blocks may have strengthened parts of the terrace, reduced the number of joints, or served as a powerful display of wealth. Whatever the reason, Baalbek was not an ordinary construction project. Its builders were transforming an entire landscape into a monument, and the stones themselves were part of them. Moving the stones began with cutting them from the hillside. Fortunately for the builders, the blocks at Baalbek were made from local limestone. Limestone can still be difficult to work, but it is softer and more predictable than many igneous rocks. Roman quarry workers could use iron picks, chisels, heavy hammers, and wedges to cut channels. The unfinished stones near Baalbek preserve parts of this process. Workers removed the surrounding rock while leaving the bottom attached to the. Once the sides had been exposed, they could continue cutting beneath the block until it was ready to be separated. But extracting an 800-ton monolith was only the beginning. The quarry was located roughly 800 meters from the temple platform. This was not a journey across an empire. But even a short distance becomes a major engineering problem when the cargo weighs as much as. No surviving Roman document explains exactly how the Trilithon was transported. Any proposed method must therefore be identified as a reconstruction, not a confirmed description of what happened. The most plausible models begin with a carefully. The builders may have placed the stone on a heavy wooden sledge and dragged it over timber tracks. Rollers are often suggested, but ordinary wooden rollers would have faced enormous pressure beneath a block of this. A sledge moving over lubricated beams or a prepared stone surface may have distributed the weight more effectively. The quarry also stood at a slightly higher elevation than the sanctuary. This could have allowed the builders to move the stone along a controlled descending route, reducing the force required to. But gravity would create another danger. The block could not be allowed to accelerate. Teams operating ropes, wooden KAP stuns, and anchoring systems may have controlled its movement from behind while other teams guided it from the front. The Romans understood how to multiply force using winches, compound pulleys, levers, and coordinated labor. Their surviving buildings demonstrate that these machines could raise substantial loads. However, the Trilithon blocks were far beyond the capacity of a single ordinary. The operation would have required an entire system rather than one remarkable machine. Several capstans could have pulled together. Large teams could operate them in coordinated stages. Timber frameworks and stone anchor points could redirect the ropes, while supervisors controlled the timing of each movement. The greatest mistake is to imagine hundreds of workers simply pulling on one rope. Roman engineering worked through mechanical advantage, preparation, and positioning the blocks in the wall. They may not have been lifted directly from ground level to their final height. Instead, the builders could have constructed an earth and rubble ramp that rose toward the platform. The monolith could then be hauled horizontally until it reached the curb. Levers, wedges, and smaller movements would have been used to adjust. As the terrace grew around it, much of the temporary ramp could be removed. This method would exchange the nearly impossible task of lifting the entire stone vertically for the more manageable task of pulling it up a gradual slope. But more manageable does not mean easy. The road had to support. Timber components had to resist crushing. Ropes had to remain under control, and every team had to act at the correct moment. A single failure could damage. The unfinished blocks in the quarry suggest that the builders were also capable of changing. Perhaps flaws appeared in the stone. Perhaps the project changed. Or perhaps the largest blocks proved too difficult. We do not know. What the evidence reveals is not a forgotten machine. It reveals something more complex, a Roman system combining geology, tools, earthworks, mechanical advantage, labor, and centralized authority. The stones of Baalbek are often presented as evidence of something impossible, but archaeology tells a more interesting story. We know that the limestone came from quarries close to the sanctuary. We know that Roman quarrying techniques were used and we know that the builders successfully positioned the three enormous blocks of the Trilithon. What we do not know is the exact sequence of machines and methods used to move them. No complete hauling equipment has survived. No Roman engineer left us a detailed description of the operation. The wooden sledges, prepared roads, capstans, anchoring systems, and construction ramps remain plausible reconstructions based on Roman technology, not confirmed facts specific to Baalbek. The purpose of using blocks this large also, they may have provided stability within the enormous terrain. They may have reduced the number of joints in the wall, or their scale may have been intended to demonstrate the power, wealth, and ambition behind the sanctuary. The unfinished stones in the quarry add another layer. They prove that the builders planned blocks even larger than those used in the Trilith, but they do not tell us why those. The answer may have involved cracks in the limestone, changes in the construction plan, or the practical limits of. Without stronger evidence, we cannot choose one explanation with certainty. But uncertainty does not mean the builders possessed a lost technique. The real achievement of Baalbek may not have been a secret. It was the ability to coordinate quarry workers, engineers, carpenters, rope makers, laborers, animals, materials, and administrators across a project that may have continued for generations. The Romans did not overcome the weight of these stones by ignoring physical limits. They succeeded by understanding those limits and organizing thousands of individual. More than 2,000 years later, the stones, not as proof that humans could not have built Baalbek, but as evidence of what human beings could accomplish when ambition, knowledge, and power were carved into stone. If you want to explore more ancient mysteries through human evidence, subscribe to Origins in Stone.